it may not all be right, or correct, or anything else. But overnight, I was thinking of well, maybe one thing or certain ways you can look at interrelationship models. And even though I did reference, parent-child relationships between entities of an ISA type, that would be modeled using either a network or hierarchical database. When I mentioned taxonomies, like you could say a sparrow is a bird, or is a type of bird. So and a male is a person. Further down that list, you could say, like students last year would have, a pilot is a person, an airport employee is a person. So why would you introduce a hierarchy, or a class view on an interrelationship model? For example, I was thinking at one point that maybe, and I'm referencing the case study now, maybe a staff member and a student are merely subclasses of the superclass, or sub-entities of the superentity borrower. But like we discussed yesterday in terms of dependency, you see, theory always comes back in again. You have to look at the attributes then of a borrower. And if you create a borrower ID, for example, as in some models, well, that's fine for a public library. But here we have a university library that is using both the student ID and the staff ID as unique identifiers for borrowing purposes. And the staff ID and the student ID are the staff numbers. The staff number, I've got a staff number. It's used for me to log on to my library. Students, they also use my name, by the way. So there's staff number and name. So that's a double thing. And then of course you have to supply a unique password. And remember, when you supply a password, the password isn't recorded as the password on the database. The encrypted digital version of the password is recorded in the password field. So there's a big hint. There is going to be a password field here, because students have to log on electronically in order to search and find and reserve, as well as rock up to the library, gain admittance via their student card. They might go over to one of the kiosks in which there's a standard computer with a web, with a browser interface to the library. Search the library for particular book titles, find them, note where they are, and physically go and get them, bring them downstairs because they're physical artifacts, and then use the same kiosk to scan the book in, and the book's ISBN code is scanned in. It calls up the book title and the author and the book details, and the student then either swipes their card, right, in order to complete, in other words, electronically their student number is put against that book, and that book is related to them for the period of the loan. So these are all the things you need to think about, and happily, right? If you've been good students, you've all been using the library at some point, and so in reading the case study, it is long. It's over 2.5, but there's diagrams in there and stuff like that, and there are sections of text that are informative and context, but will not feed into the model. The model will be okay, I didn't share the screen yet, actually. So we're sharing a window, and it's looking for windows here now. So we'll put up this one just to get the. Apologies there while I share the screen. So going back to my first point here, right? Here is a booking for a room, okay, in a hotel. You could say it's a borrowing for a book, but like the room has two types: standard and executive. Okay. So one wonders what types of books there might be. You know, you're going to have to read a case study in order to find that one out. And that's just an example I got on the internet this morning, just before I joined you. And here we have the format, a different type, right? And here we have a document code, or a document entity that's got a document code. Could be ISBN, please note. A document could be a book. A document could be a PhD thesis, all of which would be in the library, by the way. This is not a library thing. This is a generic model, okay? But what I wanted to show you in this model was the super entity document, and then 3 different types of document that are related to it, okay? So the parent document will have a certain number of attributes which describe which capture each one of those, and the child documents will have additional attributes, okay? And the purpose of this is not to have a document entity accommodating all 3 types of documents, or n types of documents, right? And adding additional attributes to the document entity to accommodate them. Because what that would lead to is lots of null fields and lots of data redundancy, possibly. And we don't want that. We like our tables to be nice and clean, to have avoid any dependencies. So for each one of these sub documents, we create, we use the document code as a foreign key to identify them, but any additional attributes, such as they are placed in those tables. And their type code is the foreign key in the document. So all we have is of a document type. So how could we use this, right? Imagine this is a book code, and it's an ISBN. And it's the identifier of this book with this title by this author. Now, this book could be in English, or it could be in French, or the original text could be in French, but here is an English copy of it. Okay? One sec there, I need to let folks in. So when you do that, then here's the original title, and by the original author, and it's in French. And then you might have type 1. Well, that's assuming it has the same ISBN, which you don't. So this is not applicable to books, is it? So we have to find a way of thinking about it. It might apply to a general type of document, such as, say, a music sheet or music score, which would be held in the library. And again, you have to think about the music score wouldn't have an ISBN because it may not be published, but it will have some form of code, and it will have a different type, perhaps. So look, it's I just wanted to show you these, not to confuse you, but to alert you to the possibility that there might be parent-child relationships somewhere in this. I'm not saying they are, and if they are and you don't model them, but your model is robust and is in third normal form, it doesn't really matter. Okay. Here we see another one, and it's in the original chain notation with the attributes as contained in the ellipses attached to the entities. So here we have books which have publishers, published by publisher. We can see the author number or author name, ISBN, title, edition, category, price. May not be relevant to us, but instead of a replacement, it might be. And it's the publisher, publisher ID, year of publication, name, etc. So readers reserve or borrow books. And for readers, you could say students or staff. And here you see it modeling user ID, email, phone number, address is a bit more on the thing, name, but name is a composite attribute, and we see that what's really being captured here is the first name and last name. Now, you know that in the Martin information engineering style of things, that we're not using that. We're using a more direct approach, so you will have first name and last name, and an address. It won't be a composite address like that. You will have a more atomic address with street number, district, city. Think of Prague and the different districts in Prague, or region. So you're not necessarily in the dark. You're operating from known examples out there, and some of them will be even more detailed than this. And so the purpose of me drawing this to your attention is that what you're going to create in the Boole library system is going to be pretty unique. Okay. So at this point, do you guys have any questions? Good morning. I need to check my chats. I haven't seen. Okay. Yeah. Okay. Aliu, do you have a question? Okay, share your screen. We see what you have. Yes. Yeah. Yeah, and that's great. That's great, Ali. Right? Um, okay, so what I want to avoid is people sharing too much of what they've done because other students can see it, and it raises the issue. Could you just go back up to library catalog and just focus on that there? Yeah. Um, And this is a philosophical question. And if you hold that 1 second, I just need to go and get my phone because it's been dinging left, right, and center.
Nice one, Ali.
Okay. Um, I think in identifying the library, okay, in identifying the library catalog, for example, as an entity, okay, um, that's a fundamental error in entity relationship modeling. Okay, we're trying to create a model of the electronic library catalog. Okay. Okay. So every student makes this error, right? Um, and have you done data flow diagramming or process modeling? No. Yeah, it's not quite a flow chart, yeah, but it's a process of how data gets moved around. You need to map the processes, right? Okay, yeah, but students have there is a natural tendency to actually put the system in as an attribute itself, whatever the area is, right? Or even you found it in the in during the lectures this week. Um, what was it again? There was oh God, it's have to slip my mind there now. Um, but let's look at this, right? When you look at the library, just walk into the library now, and speaking to everybody here, just walk into the library. You see students, you see librarians, you see books, you see recording digital, you see CDs that are digital recordings of books, all the physical things, right? You will see music scores, you will see all arranged in the shelves, you will see all the books in the shelves, all divided up according to the Dewey Decimal System and categorized accordingly. Um, um, you will see professors in there and lecturers as well, either reading books that they have just taken off the shelf or carrying out of the library and borrowing. Okay, all of these, right, are the physical entities. They're the analog things, right? You'll see students returning books, right? You will see librarians speaking to students, typing in details, um, searching for things, and maybe handing back to students a slip of paper saying, "Well, it's here," or "You can't take it from the library, but go to the third floor, and the librarian there will give you the book to read. You can't take it out." But the thing is, right? The thing is, right, is nowhere you will find here the library catalog, okay? Except when you go to a computer terminal and you either search the library or log in to your own account in the library, and that's the catalog. It is the system itself. It is the catalog is the digital representation of all of these things. Exactly. That's why, right? So let's look at the case study itself, and stop sharing your screen and I'll share mine. Now, what I don't want to do this morning, right, is, and you guys would be delighted, for me to actually do it for you. And that wouldn't be fair. It wouldn't be fair to people, guys like Aliu, who's well advanced, right, in and has kind of grappled with the problem. And I could see from his diagram that he's made some significant progress and made mistakes as well. But everybody makes mistakes when you're doing this for the first time. So nothing new here, right? So see the first paragraph here, right? That's only informational. That's only here, right? It's right, and music CDs. Now there are other things. So all of these are as the things, right? So straight away, that paragraph, you should be parsing down and saying, these are the candidate entities. When I say candidate, we might be changing the titles, but it's a good place to start, okay? The last two sentences in that are just saying, why we're building this model, because the library is replacing. This is just telling us what the library has, okay? So it has all these members, and later down in the text we find these members are actually made up of two categories: university staff, which include the librarians. So that's a parent-child relationship, and students. Okay, so these are members, but librarians are also, besides being members, they're administrators of the system. They must log on to the system too, and they can do things in the system. So they are another entity. Okay. Now you guys need to figure out, librarians don't have a librarian ID. They have a staff ID, which means the librarian entity is going to be connected to the staff entity. Okay. So you have, in the first paragraph there, you have so much information. And the second paragraph extends that and mentions the point I just made. So the third paragraph deals with the question of where we get the information on members from. When a new staff member joins the university, his or her information is extracted, transformed, and loaded from the employee records. Now, not all of the employee records, right, are taken across, and this will be done via query, a SQL query. So a SQL query to this database will extract information like staff number, staff name, staff department, what else? Staff address, in the university, home address, perhaps because of correspondence, email, telephone number, so all of that those attributes need to be extracted here and copied into the library database. Okay. Similarly with students, when students enroll and when they register, their data is taken across. Now, the student fundamental data, when they join a course, business rules then have to be applied, right? Do we do this every semester? No, that's a huge overhead. We have to assume that when students enroll in a degree program, they're going to be there for the 4 years as an undergraduate. If they, enroll in for the first time in the university in a postgraduate program, we have to assume they're going to be there for the period of time indicated. And so they become members for that period of time, unless, of course, they stop being a student, in which case an alert is sent to the library. But, but the student information, again, the relevant student data is transferred in. Student number, okay? The library doesn't issue student cards. That's the registrar's office. Or in terms of employees or staff, their cards are issued by HR. So they're outside the system. All we know is they have a staff number, and when they rock up, they'll swipe into the library with their card, and that will indicate to the library system that the student has entered the library, and they will use the same card when they book out, or when they borrow a book or any other item. They will scan the card, the barcode, right? It will take their student number and update their borrowing record. So a staff member and a student and a librarian as staff will have a borrowing record of borrowing details for particular books or other artifacts. So that paragraph indicates the type of data that the library system is going to capture for each member, staff and student, okay? And because the staff includes librarians who are also members of the admin system, that needs to be linked. Now, the thing is, right, imagine you have somebody working in the library as a librarian, and they're a member of staff in university, and they decide, I'll apply for a promotion in the Department of Economics. So they apply for that, they get the job, they're no longer librarians, they're a senior administrator in the economics department, they're still members of staff. The only record that's deleted in the library is their role as their position of librarian, okay? They still exist as, so any books that they do borrow need to be recorded accordingly. Do you see what I mean? There are rules here that you need to kind of accommodate, but you don't need to capture the behaviors. All you need to do is design the database in such a way that it accommodates these eventualities. Because as we discussed yesterday, we don't want orphan records. We don't want update and delete inconsistencies. In other words, when we delete a librarian from the librarian table, the individual will still exist as a member of staff and is entitled to borrow books, and therefore the way we track how they borrow books must be as a member of the general staff, not as a librarian. So their role in the system as a librarian and their access will be different. That's just one thing, probably even the major thing, right? Everything else is straightforward. And the next paragraph indicates the different categories of or roles of librarians, okay? And just indicating they have administrative activities. Okay, the next catalog. The library's catalog of books. Oh, of books and books. Oh, didn't I make a mistake there? I think I need to change that. Will you guys take a note of this? The library's catalog of books and ebooks. And music CDs must be available online. Okay, this online catalog may be accessed through any device and using computers provided for that purpose in the library. Again, that just helps you visualize what's going on. It doesn't say anything about the entity relationship modeling. It just signals, right, that we have books and ebooks and music CDs, all of which can be borrowed. And I think there's book CDs as well. Books, ebooks. Yeah. Yeah, but yeah, you're right. It's the information is contained elsewhere. with us. Okay, so yeah. The important thing is that the catalog lists books by author, title, year, and subject area, and other data presented below. So here's the other data presented below. The system must record details of each item borrowed by the library. Each book is uniquely identified by its ISBN. So that will be the key identifier, which is unique international code assigned to all books. So no two books will have the same ISBN. Some books are published by different publishers. Hardback publisher might publish the hardback, the softback. To my knowledge, they'll have different ISBNs because they have different publishers, even though they're the same title. They're two different types of book in any case, hardback and paperback. Okay. Or hardcover and softcover. So I mentioned that there. Editions of books, first edition, second edition. So you can see the what that paragraph does, right? Is it fleshes out the attributes that books have, okay, in order to give you as much information as possible about those attributes and about the need to capture and not go simply by author or book title, because that can confuse. And even in somewhere in here, books will be published in different languages. So when for example a student searches, we don't know what the ISBN is. So we might search for books by author, okay? So when that happens, right? Yeah, the book title and author are input, and up will pop as a search result, which means it must be in the database. All of those books titles, right? Their ISBNs and editions and year of publication and language, because some international publishers, say if they're publishing in French and somebody is studying French, will be interested in the French edition, but might also wish to look at the English edition and the translation. If they can't understand complex French references or words, well, they have an English one to compare with. So in that case, the search will also, indicate the existence of the English copy and where it is. So you have all of these things that you must think about, because it will determine how you treat the book entity, how you develop the book entity. You must, the key thing here is ISBN. So here's a short paragraph that is relating to music scores. They're catalogued by genre. As we'll see below, genre is classical, rock. You know what genre means. You're all interested in music, and if you want to find a bit more about it, just Google. And all music scores tend to be published, even for pop stars, because they've got copyright over it, and anybody who wants it can buy it, and if they buy it, and it can be borrowed. Typically by music students, but just about by anybody. I mean, might have somebody studying engineering or science, and they're big into a particular type of music, and they might want to get the score so they can play it on their guitars, pianos, or whatever the music they're interested in. Um, while music recordings in CD format also have performer, company, year, and so on. Scoring CDs electronic borrowing and return. There will be a unique identifier for all books and CDs, and the barcode, it would be into them so they can be scanned out. Okay, but the thing is, the mechanism of the data input output is irrelevant here, right? The fact that there is a unique identifier for a score and a CD, okay, it is the important thing, okay? Remember, we're creating a digital version of a physical reality. And in reality. Okay. Here's a different term, right? Books are purchased and included in the library on the recommendation of individual academic departments. These are discipline-based, computer science, blah, 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 and each department is allocated an annual budget to purchase new books. So that has to be captured. So there is an entity department, okay, and it'll have a department name, might have a department ID number, have a department name, contact number. Each department will have a library representative, by the way, and it'll have a budget, and that budget will be allocated. And so it gives them the ability to request the acquisition of books and for inclusion in the library catalogue. So that process has, so that request will be to a librarian, and that request has to be entered into the system as maybe a table of book purchases. So the link between the foreign key, right, in that entity will be the department ID. Okay? So you need to imagine, you need to build up these mental models for each paragraph. And the only way you're going to do that properly is if you follow, this is page 1 there now. So if you follow this approach, right? Now, Ali a while ago had shown me his workings, right? So this is vital, right? It only gets 30%. The model gets 60%, right? But it's very, very important. But because it shows me, it demonstrates to me, if I see your workings, it'll be unique, right? And it demonstrates to me that you actually put the work into this. And the only way you're going to create the diagram properly is if you go through it and you identify the entities, the relationships, what type of relationships it is, and you will identify many-to-many relationships, and you'll identify how which means that your model is in first normal form, in effect, or might be even in second normal form. But in order to remove those and get into third normal form, you need to absolutely eliminate all M-to-M, M-to-N, many-to-many relationships. If I see any many-to-many relationships in any model, I will mark it down heavily. I'm going to repeat to all of you now listening, and I hope you're listening, and I'm going to type it in as a message to everybody, so you'll see it all. Only one-to-one. Or one-to-many. Okay? Otherwise, there will be consequences. Right. What I want you to do now, right? I've gotten so far in this. I've gotten as far as here. It is 10:03. I've been speaking for 45 minutes. I suggest that we take a break for 10 minutes only. There's 87 students in attendance, and that's very, very good. So what I'm going to do is I'm going to knock off my mic and my video, and I will see you in 10 minutes time, okay? So please stay logged on.